Next book I want to talk about is one by Edwards. It's the historical development of the calculus, which is basically about history of calculus and exactly how Newton found his stuff. So we see it starts with area, number, and limit concept of antiquity, Archimedes, twilight, darkness, and dawn, early indivisibles and infinitesimal techniques, early tangent constructions, Napier's wonderful logarithm, the arithmetic of the infinite, the calculus according to Newton, the calculus according to Leibniz, the age of Euler, and the calculus according to Cauchy, Riemann, and Weierstrass. And then the 20th century, where they talk a bit about the Lebesgue integral and non-standard analysis. So like all of Edwards' books, Edwards has a book on Galois theory done historically. He has a book on Fermat's last theorem historically. He has some other historical books. This is again a book which tries to formulate how calculus was invented historically. And it's, of course, a fabulous book. I think it's very worth knowing. I think it's a very nice complement to other books of the type, other books of calculus, because it really talks about where things come from, where they were invented. The problem with books like these is that in the past, ancient Greeks used a different language than today. They used the language of geometry. As you can see, things here are geometrically very complex, very complicated, like they did here, like Riemann integration done geometrically. That can be very difficult for people to really grasp. But I think it's a really really well written book. Of course, it's probably a very good precursor to Brissot, his book on analysis. I of course highly recommend this book to anybody interested in history. It's absolutely wonderful. It's absolutely beautiful. Brissot is another book. He has like a book, Calculus Reordered, which I also recommend, and I think they complement each other pretty well. So yeah, again, like other Edwards books, this is one I really cannot recommend highly enough. Here we see a book, Black Body Theory and the Quantum Discontinuity by Kuhn. Kuhn is the same philosopher, Kuhn, which is a physicist who really wrote a lot about philosophy and how to interpret new physics. And he invented the concept of paradigms in physics and paradigm shifts and revolutions. Yeah, so this book is really about the history of a particular problem, the black body problem. So it starts with Planck's root to the black body problem, Planck's statistical heritage, Boltzmann on irreversibility, Planck and the electromagnetic age theorem, Planck's distribution law and its derivations, the foundations of Planck's radiation theory. In part 2, they talk about the emergence of the quantum discontinuity, dismantling Planck's black body theory, Ehrenfest, Rayleigh, and Jeans, a new route towards black body theory, Einstein, converts to discontinuity, black body theory and the state of the quantum, and then finally the epilogue, Planck's new radiation theory. So it really talks about how black body theory was done, why it was invented, how it was important for quantum theory. So if you're interested, of course, in the history of quantum physics, quantum mechanics, I think this is again a very good book written by Kuhn, which is of course a big name in the field of philosophy and history and physics. So yes, extremely worthwhile book. Next we have a book on quantum physics by Lvovsky, an introduction based on photons. So what does the book cover? It starts with the quantum postulates, and it starts with Hilbert spaces, and it's then they cover entanglement, the one-dimensional motion, then angular momentum, quantum physics of complex systems, and then some appendices on linear algebra, probability, optical polarization, and Dirac delta functions. So this is really based on the conception that the theory of light and the theory of quantum mechanics are very alike, as of course they should be. And this book tries to take full advantage of this and to explain quantum mechanics. I'm very interested in this book. I haven't read it yet. I just received it today. So very interested in working through this book and seeing what it is like. Yeah, it looks pretty good. Then we have a book, Classical Mechanics and Electrodynamics by Linus. Pretty short book, and it's part 1 is on analytical mechanics, which starts with generalized coordinates, Lagrange equations, Hamiltonian dynamics. Then it goes off to relativity, the 4-dimensional spacetime, consequence of the Lorentz transformations, 4-vector formalism and covariant equations, relativistic kinematics and relativistic dynamics. And then it goes to electrodynamics, where it does Maxwell's equations, electromagnetic field equations, Maxwell's equations with stationary sources, and finally electromagnetic radiation. It's a very short book, and it tries to do all these classical fields from a very advanced point of view, which I think I really appreciate. The book looks pretty good, pretty doable, pretty concrete. It doesn't go too far into the mathematics, but it stays pretty close to reality. So yeah, very nice book. Not sure I would really recommend it, even though it looks good. I guess for our advanced students who really want to see the connections between these fields, I would recommend it definitely. Then we have Classical Mechanics and Quantum Mechanics, a Historic Axiomatic Approach by Enders. So in this book we start with introduction, where they talk about classical versus quantum, what is quantum. Then we talk about the Newton-Eulerian axiomatic, the notion of state. We talk about conservation of stationary state motion. Then alternative axiomatic energy conservation. Then why quantum mechanics, a hierarchy of selection problems, non-classical energies, stationary Schrödinger equation, non-classical solution methods, additional results, conservation and change of stationary states, equation of motion, conservation laws, applications, and space-time symmetries, gauge symmetry, permutation symmetry, I-quad causa effectum, coupled classical oscillators from chains to strings, quantization of the string, free electromagnetic fields, and finally summary and conclusions, some open questions, and the points of extension and generalization. So yeah, it's a very novel approach to these topics. Definitely not a first-time book, but it tries to bring the connections between all different fields and all different ways of looking at things, also from a very historical point of view. So yeah, looks like a very interesting book, definitely. Next we come to a book by David Williams, Probability with Martingales, where we have measure spaces, events, then we have random variables, independence, integration, expectation. We have an easy strong law, product measures, and then we finally come to martingale theory, conditional expectation, martingales, the convergence theorem. We have the martingales bounded, uniform integrability, UI martingales applications, basic properties of CFs, weak convergence, the central limit theorem. So a pretty rigorous book with measure theory. Starts off with a rigorous measure theory on martingales, and it tries to take the martingale point of view really seriously in this probability book. So yes, Williams, of course, is a very good writer. I really like his writings. But yeah, it's a fairly advanced probability book for Czechs. So yeah, I would recommend a book like this. If you're not really too into rigorous probability theory, then perhaps not. Then we have a treatise on the dynamics of a particle by Tate. That's actually by. So it's a very old style book. It's very old, as you can see. So it starts with kinematics, laws of motion. It talks about rectilinear motion, parabolic motion, central orbits, constraint motion, motion in a resisting medium, general theories. Then it goes towards impact, motion of two or more particles. So yeah, it's a very old book on these topics of motion, very classical theory, stuff that you don't really cover anymore today. So of course that's something like that is very cool to me. All this knowledge that's kind of forgotten, and you don't really see things this way anymore. It's very interesting. Next, we have a book on mathematical physiology, on cellular physiology. So yeah, it talks about mathematics of the human body. So here we have biochemical reactions. We have cellular homeostasis. We have membrane ion channels, passive electrical flow in neurons. It talks about excitability, wave propagation, excitable systems, calcium dynamics, intercellular communication, neuroendocrine cells, and it talks about regulation of cell function. The second volume on the circulatory system, on the heart. We have a section on blood, respiration, muscle, the endocrine system, renal physiology, the gastrointestinal system, retina and vision, and the inner ear. So yeah, all about physiology and how mathematics can be used to understand that better. Of course, I'm very interested in applications like this to see how we can really use math to understand this stuff. So stuff like this is very interesting to me. And then finally, we come to two books of yoga. We have the key muscles of yoga, and then we also have the key poses of yoga. So it talks about the different poses and how the muscles influence it. And the first volume is the key muscles of yoga, where it talks about the different muscles and how they behave. So scientific, try to be a bit scientific about yoga practice and exactly what muscles it influences.